Now that we know how to use SOHCAHTOA and we know how to use our calculators to find angles and sides that are missing on a right triangle, let's go ahead and look at solving right triangles. Now when we talk about solving right triangles, we're finding all three angles, all three sides. And sometimes much of that information is given to you, but that's what it means to solve a right triangle. Find the measure of all angles and all sides. Now usually we have C as the right angle, and then A and B are our other two angles. So for this particular triangle, and most of the triangles that we're going to be working with, the angles that we have listed here are the capital letters A, B, and C. And then the sides would be the lowercase. Well, the side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So our sides are lowercase a, b, and c. Now C is usually the 90-degree angle. And then side C, that's the lowercase c, is the hypotenuse. Okay, so that's usually the setup that we have when we're trying to solve right triangles. And again, when we're solving a right triangle, it has to have a right angle here. Okay, so that right angle must be present. Also, do not round in intermediate steps. And this will make more sense when we get to some problems. Because if we start rounding at the beginning of the problem, by the time we get to our final answer, there's probably quite a bit of error that's been introduced. So do not round till the final steps. Okay, so for an example, let's go ahead and pull one from my math lab and solve a right triangle. So here they just give us some information. They don't give us a picture to go off of, so we'll need to draw our own. It says solve the right triangle ABC with C equals to 90 degrees. So they're giving us that 90-degree angle to make sure that we have everything labeled correctly. So C is this 90-degree angle. That means the side opposite is lowercase c, and they tell us that that's 18.8 feet. And then they tell us that angle A is 45 degrees. Now it wouldn't matter if we put A up top or on the bottom, as long as side opposite was the lowercase a. We just have to be consistent. I'm going to put it down here to be consistent with our picture we have up above. And then side A would be over here. So now what they want us to do is they want us to find the measure of angle B. Well, this one's pretty straightforward. So the angle B is going to equal 180 degrees minus the 90-degree angle minus the 45-degree angle. So that would leave us with 45 degrees. So angle B, which is at the top here, is 45 degrees. Okay? Now remember, when we say to solve a triangle, we're saying find all angles and all sides. So what we have done so far is we have found one angle. So now we know all the angles, and now let's go ahead and go find all the sides. So to find the rest of the sides, we could start setting up some, let's go side B here on this one. We could start setting up some trig information. So for instance, if we wanted to find, let's say, side A, we might be able to use Pythagorean's theorem. Now, a couple things I know here. Because I have two equal angles, I have two equal sides. So side A equals side B, because this is an isosceles triangle. Okay, and that basically means I have two equal angles, two 45-degree angles. So here I could say A squared plus B squared equals 18.8 squared. But what I know, since side A and side B are the same, I could just call this A squared plus A squared equals 18.8 squared. Or 2A squared equals 18.8 squared. And then we're actually going to have to multiply this out. So 18.8 squared is 353.44. So 2a squared equals 353.44. Divide both sides through by 2. And I get a squared is equal to 176.72. Now, in order for me to figure out what a is, I would need to take the square root of both sides. So I'd have a equals the square root, and I'd get 13.29360749. Now, I also know that this is the same as b because this is an isosceles triangle. 2 equal angles means I have 2 equal sides opposite. Now, for my angle, for angle B here, 45 degrees, it says type an integer or a decimal. So my 45 would go here. I don't need the degree because it's already on the outside of the box, so I just put in a 45. Now for my side A and my side B, they would probably want me to round this. So let's say they're asking us to round this to the nearest tenth. So side A equals side B. Now one other quick note, when I take the square root, I do get plus or minus, but this is the length of a triangle, so I'm going to be looking at the positive. So this would be 13.3 if I round this to the nearest tenth. And this would be feet. So if I round this to the nearest tenth, I'd go to the 10th position, and then I'd go to the 9, and that would round the 2 up to a 3. So this is an example of solving a right triangle. All the other information was given. I didn't need to solve for that. So on the next one we're going to look at, we're given a little bit different information. We know that it's a right triangle, so we know that there's a 90-degree angle involved. But let's go ahead and sketch things up and draw out what we have so we can try and solve it. So let's go ahead and put up our 90-degree angle. We're going to call that angle C. And again, A and B don't matter which one we call them, as long as the side opposite of A is opposite of angle A, and side opposite of angle B is side B, and then side opposite of C, of course, would be the hypotenuse. And we're given that C is equal to 46.1 centimeters, and we're given that A is equal to 19.4 centimeters. So we do need to find B, and then we need to find angles A and B, and we do know C already. So I think the easiest thing to do to start with is be to find side B. Now since this is a right triangle, we should be able to use the Pythagorean Theorem. And the Pythagorean Theorem says legs squared plus legs squared will always equal the hypotenuse squared. Okay, so solving here, I take 19.4 and square that, and I get 376.36 plus b squared is equal to 46.1 squared, 2125.21. And then solving for b squared, I would take 2125.21 minus 376.36, and I'd have 1748.85. Now this is what we mean by not rounding. For instance, I wouldn't want to round this to 376 and this one to 2100 or something like that. We always want to carry it out all the possible decimal places. Now to solve for b from here, I would take the square root of both sides, and I would end up with b equals 41.81925394. Now, for this particular problem, the instructions are to round to the nearest hundredth. So to round to the nearest hundredth, I'll go out 2 decimal places to my hundredths position, and then I go to the next digit, and if it's 5 or above, I increase that value. So my value for b in this case would be 41.82. So b is 41.82. And what do we have here? Centimeters. Okay, so next, if I look at my picture, this is that 41.82. I know that this is 90 degrees because it's marked. I need to find angle A and angle B. So I want to figure out how I can do that. It doesn't matter which one we find first. I want to start with angle A. So to find angle A, which is right up here, I look at my values and I was given the side opposite and the side that's the hypotenuse. I don't want to use this adjacent side in case I have something wrong. So if I have 41.82 wrong, that would make my next answer wrong as well. So for sine A, I'm thinking I have opposite and hypotenuse. So let's use the sine because sine is opposite over hypotenuse. And I have those two legs. So I have the sine of A. I have one of those legs, I should say. Opposite leg is 19.4, and the hypotenuse is 46.1. So this would mean that A would equal the inverse sine. I would take the inverse sine of both sides, or the arc sine of 19.4 over 46.1. So let's go ahead and grab our calculator. I think I have it up here. So we'd want the inverse sine. I'm going to use my alpha y equal key here for my fraction. And I have 19.4 divided by 46.1. I'm in degree mode. I should always double check. And I get 24.8866. 3962. So 24.8866. 3962. Okay, so looking at the instructions for this in my math lab, it asks us to round to the nearest minute. Okay, so this is in degrees. So our instructions on this are to round to the nearest minute. Now it's been a while since we've done one of these. So the way we would round this to the nearest minute is I would take 24 degrees plus, this says 0.88663962 minutes, and there's 60 minutes in 1 degree. So I would take that value, 0.88663962 times 60, and that would give me 53 minutes. So this would be 24 degrees plus 53.1983772 minutes. Now if I round this to the nearest minute as this shows, this would be 24 degrees, 53 minutes. Now this 0.1982, that means about 19 or 20% of a minute, which wouldn't be enough to round it up to the next minute. So A is equal to 24 degrees, 53 minutes. So let's go label that up here. So A equals 24 degrees, I already forgot it, 24 degrees, 53 minutes. Okay, so now if I want to find angle B, I could set up a trig ratio, or I could use the fact that I know 90 and 24 degrees 53 minutes and subtract that from 180. However, if I do that, what if 24 degrees 53 minutes is wrong? That's going to make B wrong too then. So I think instead of doing that, what I'd like to do is I'd like to look at what's given. These two are given. And for our trig ratio from angle B, this would be adjacent and hypotenuse, so that would be a cosine. So let's go ahead and find angle B next. So the cosine of B would equal adjacent over hypotenuse. So cosine of B, let's run up and find those numbers. My adjacent leg was 19.4. My hypotenuse was 46.1. So solving here, I would take the inverse cosine of both sides and I'd get B equals, my angle B equals inverse cosine of 19.4 over 46.1. So plugging that into your calculator, let me see here, I get arc cosine. May as well use the calculator on the screen here. Arc cosine, I'm going to use my fraction key, alpha y equal, and I have 19.4 divided by 46.1. And I get 65.11336. 038 degrees. Now we want to round this to the nearest minute. So if I round this to the nearest minute, I would have B equals 65 degrees plus 0.11336038 times 60 minutes. Now what you don't want to do is to take this 0.11336 and round it to like 0.1, because what ends up happening then, that's over rounding, and that might throw off your final answer. So if I take the 0.1136038 times 60, I get 6.816228 minutes. Now this is more than half a minute, so it should round this up to 7. So this should look like 65 degrees, 7 minutes. So let's look to see what we have here. Kind of to summarize, since I have things all over the place, I have side A, side B, and side C. And then I'm going to have angle A, angle B, and angle C. Well, the one I remember for sure is that angle C was 90 degrees. So let me go grab the rest. B, we have right here, angle B. I have this messed up. Our angles are capital letters. I'm used to using Greek letters. So this is 90 degrees. Angle B is 65 degrees, 7 minutes. And then angle A would be 24 degrees, 53 minutes. 24 degrees, 53 minutes. Okay, so now let's find our sides. So 41.82 was B. A was 19.4. And C was 46.1. Now, a couple things I want you to look at here. Notice that C is the largest angle and its side opposite is the longest side. A is the shortest angle, or the smallest angle, and A is the shortest side. So that should always happen. Longest side, it will be opposite the largest angle. Shortest side will always be opposite the shortest angle, and of course the medium is in between here. So that kind of summarizes my triangle. Now here's just a quick check. If I wanted to check this, I could say, okay, leg squared plus leg squared better equal hypotenuse squared, if this is correct. And when I add up all the angles, I better get 180 degrees. So that's another thing that I can check. But let's go ahead and look at the 19.4 squared. I get 376.36. 41.82 squared. 1748.9124. And I'm checking to say, does this equal 46.1 squared? and that's 2125.21. So again, that's 376.36 plus 1748.9124, and I get 2125.2724, 21.25.21. So these are approximately equal. Because of rounding error, a little bit of rounding in there, I'm not getting exactly the same, but you can see that they're very, very close, up to, it looks like tenths. And if we look at rounding, probably up to the ones position. Now another checkpoint would be to add up my angles. So if I had 24 degrees, 53 minutes, and 65 degrees, 7 minutes, and I added those together, this would give me 60 minutes and 89 degrees. But 60 minutes is a degree, so this gives me 90 degrees, plus this other 90 degrees equals 180 degrees. So this definitely checks. So my angles do check out really nicely here. And it's not a bad idea, especially on a test or a quiz when you don't want to redo something, that you double check these to make sure they're either in the ballpark or spot on. Now before we can work our next couple problems, these are going to be more like story problems, we need to define a couple things: angle of elevation and angle of depression. So if I look at angle of elevation and angle of depression, they're different. But they're both measured from a horizontal, so that's one thing that's common about them. So for an angle of elevation, what I do is I kind of start on the bottom and I look up. So that's my elevation. So this is my angle of elevation. So if I was to look up from, let's say, point X to point Y, that would be my angle of elevation. Okay, next would be my angle of depression. Angle of depression, I'm also going to be looking from the horizontal, and I should write that in here. This is a horizontal line. So I'm also looking from the horizontal, but instead of looking up, I'm looking down. So if I'm standing here at X, or I'm looking out a window at X, and I look down toward this point, Y, let's say, this is called my angle of depression. Now because we already say the word depression, that's already telling me it's moving down. So this is actually a positive angle, as is the angle of elevation. Okay, so because we say angle of depression, that takes care of the fact that it's negative. So I don't need to have a negative value in front there. So let's go ahead and pull a question from your homework, something that you're likely to see during your homework, and see if we can figure it out based on using the angle of elevation and the angle of depression. Okay, so here is a nice drawing. That's always helpful. It says a safety company committee has recommended that a floodlight be mounted in a parking lot. So this is the floodlight right up here, so as to illuminate the employee exit. And this is the employee exit, this door right here. Find the angle of depression to the nearest minute. Okay, so let's keep that in mind. So the angle of depression is right here. So if I draw this triangle out, I have this right angle right here. And if this is 39.03 feet over here, this is also 39.03 feet over here, because I have this nice little rectangle I've made now. And if this is 51.6 feet on 66 feet on the bottom, this is also 51.66 feet on the top. So I know two sides, and I know this angle that I'm looking for right here. Well, this is my hypotenuse. And so what I have here is an opposite and an adjacent side. So what trig identity, or what trig function, deals with opposite adjacent sides? That's tangent. So the tangent of theta is going to be equal to opposite over adjacent. So the tangent of theta is equal to 39.03 over adjacent, which is 51.66. And then to solve for theta, I would take the inverse tangent of both sides. So theta, the inverse tangent of the tangent is just theta, would equal the inverse tangent, or the arctan, of 39.03 over 51.66. Okay, so let's grab our calculator. Let's look at the inverse tangent. I'm going to use my fraction key, alpha y equal, and I have 39.03 divided by 51.66. Arrow out, close parenthesis. I am in degree mode, and I get 37.07166. So I get theta equals 37 point, I already forgot it, 07166. 07166,121. Now, nearest minute. So rounding this to the nearest minute, I would say theta equals 37 plus 0.07166,121 times 60 minutes, because this is talking about the part of a degree that it is. So if we plug that into our calculator, so let's come over here. So I'm taking that decimal times 60. I get 37 plus, that's degrees, plus 4.299672606 minutes. Well, if we're asked to round this to the nearest minute, this would be 4 minutes, because this is not half of a minute to round it up. So theta would equal 37 degrees in 4 minutes. Okay, so that's how we can look at this. Now this problem could be solved differently as well. I could have come and worked on this bottom triangle instead. And then once I found this bottom triangle and found this angle, then I would know this is a 90 and I could solve from here. But I think it's easier probably just to go with the first triangle right away instead of trying to solve for 2. It kind of introduces a little bit more error. Okay, let's go ahead and look at one more problem. See if we can find a good one. Okay, so this one is interesting. It kind of has to do with that very first lecture that we had. It was talking about how we find elevations. And this one has a nice picture, so that's always helpful. Better not distort it too much though. Okay. So it says the altitude of a mountain peak is measured as shown here in figure at the right. So at an altitude, I might have to blow this up on the side screen so I can see it. Whoops. Okay, so the straight line, so the altitude is 14,551 on this bottom peak. So I'm going to blow this up a little bit. So starting at this point down to the base, we'll say the ground, is 14,551. Okay, and then they draw this horizontal line, and then they have this angle of elevation to this other peak. And then what we can do is drop an altitude down to that horizontal line, and then they give us this angle theta in the picture as well. They tell us that this is 27.6874 miles. So this one's going to be tricky because we have miles and feet, so we need to keep track of that difference. Okay, so let's see what we can do with this now. So looking at here, they also give us this angle of elevation, and it's 5.8300 degrees. And the zeros are in there to show that it's very accurate measurement. They want us to find the height of this larger peak. Well, once we find this height right here, we'll call this H, I need to remember to add the height of the other mountain to it as well. So I think in looking at this, we have opposite and we have hypotenuse. So if we use opposite and hypotenuse, that would be the sine. So we have sine of theta is equal to opposite over hypotenuse. So theta we know is 5.8300 degrees is equal to my opposite side, which is the height of the mountain, over the hypotenuse, which is 27.6874 miles. So let's remember that miles bit. So if we solve this for h, what we would do is we multiply both sides by 27.6874 miles. So we multiply this side also by 27.6874 miles. Over here it cancels, and I'm left with height equals 27.6874 times the sine of 5.8300 degrees. When I get done with this, this will be miles. So let's go ahead and plug this into the calculator. So we have 27.6874 times the sine of 5.8300, and the zeros don't end up mattering right here. Degrees, and we learned last time if this is in degree mode that we don't have to have a degree mark here, but I'm going to go ahead and insert it just so I remember that I am in degree mode. So here for my height I get 2.812. I don't want to round that at all, so let's find the rest of that. I get 2.812408.612 miles above the peak that's right here. Now I need to add to that 14,551, not miles, but feet. So I either need to convert both of these to miles or both of these to feet. Okay, so I think the easiest thing would be to look at the instructions, and the instructions want feet. So that means I need to convert this to feet. And there's 5,280 feet in a mile. So for my height here then, let's see if I can pop that back in. I had my miles here, so I'm going to take that answer times 5,280. So that's the height that I found over here. Then I'm going to add to that 14,551 because that's going to give me my total height from the ground. So this is 29,400. And let's see, rounding, they want us to round to the nearest foot is needed. Okay, so the nearest foot is as needed, 29,400.51747. So if we rounded this to the nearest foot, our height would be 29,400 feet. Actually, this 5 right here would round that to 401, which is pretty amazing because Mount Everest is not that high. So that's a pretty high peak. So 29,401 feet would be the answer to part A. Okay, now let's look at part B. Part B doesn't really take into account calculations, but it says in the actual measurement right up here, Mount A was over 100 miles away and the curvature of the Earth had to be taken into account. Would the curvature of the Earth make the peak appear taller or shorter than it actually is? Well, if you think about looking at something on the horizon, is it shorter than it appears? Or does it appear shorter than it actually is or larger than it actually is? as you get closer and closer to it, it appears larger because you're getting closer, but also because of the curvature of the Earth, as you get closer, you can actually see the true height of it. So this would be shorter. Because of the curvature of the Earth, would the curvature of the Earth make the peak appear taller or shorter than it actually is? And that's shorter from this point. Okay, so those are a couple of examples that you can work through when you get to your homework as well. They're kind of fun examples. Make sure you take into account that difference between the units of miles and feet if you come across that one. As usual, if you have questions, just let me know. Good luck.